Pak Aryo, punten, apakah sudah jam 9 ya? Apakah bisa langsung dimulai atau masih menunggu yang lainnya baru berapa? 24 ya? 51. Belum ya? Gimana Bu? 9 ya? Gimana? Udah mulai? Udah jam 9. Hmm. Baiklah, Pak Aryo, punten. Apakah sudah bisa dimulai, Pak? Belum ada respon.
Mulai saja Mbak Mary.
Oh ya, baik-baik. Terima kasih, Pak. Ya, baiklah, akan kita mulai. Apakah suara saya terdengar? Sudah ya, berarti aman ya. Oke, terdengar ya. Terima kasih. Oke, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Selamat pagi, salam sehat untuk kita semua. Yang saya hormati Kepala Pusat Riset Lingkungan dan Teknologi Bersih, Bapak Dr. Aryo Beta Juan Silvero. Yang saya hormati Ibu Noor Elisa Tajidin Ph.D. dan Dr. Elisa Azura Rahman dari Universitas Putra Malaysia, dan seluruh peserta hadirin BRIN EnviroTalk ke-36, baik yang hadir secara virtual melalui Zoom maupun yang mengikuti berlangsung di tempat. Saya ucapkan selamat datang dan terima kasih atas kehadirannya. Perkenalkan, saya Mary Jayanti, di sini menggantikan Dr. Asep Mulyono karena berhalangan hadir sedang mengikuti agenda penting terkait pembahasan PKR 2024 dengan bagian pendanaan riset BRIN. Baiklah, pada kesempatan kali ini saya akan memandu jalannya BRIN EnviroTalk ke-36 yang diselenggarakan oleh Pusat Riset Lingkungan dan Teknologi Bersih BRIN. Adapun tema besar acara hari ini adalah Sustainable Agriculture, Local Solution, Global Impact yang bertujuan untuk memperkuat kontribusi riset terhadap pemulihan dan peningkatan kualitas lingkungan. Riset yang dipaparkan hari ini sangat penting untuk diketahui dan dikembangkan lebih lanjut demi keberlanjutan lingkungan yang lebih baik, terutama bagi Sipitas, Badan Riset Inovasi Nasional, maupun masyarakat luas. Sebelum kita memulai acara kali ini, izinkan saya menyampaikan urutan acara yang akan kita ikuti bersama pada hari ini. Yang pertama, pembukaan oleh saya selaku moderator, sambutan Kepala Pusat Riset Lingkungan dan Teknologi Bersih oleh Dr. Aryo Beta Juan Silvero, presentasi yang akan dilakukan oleh narasumber kita, Ibu Noor Elisa Tajidin Ph.D., kemudian presentasi kedua yang akan dipaparkan langsung oleh Dr. Elisa Azura Rahmat, yang merupakan dosen dari Universitas Putra Malaysia. Kemudian sesi diskusi dan tanya jawab, dilanjutkan sesi foto bersama dan penutupan acara. Baiklah, para peserta, kita akan memulai acara kali ini dengan sambutan langsung dari Kepala Pusat Riset Lingkungan dan Teknologi Bersih, Bapak Dr. Aryo Beta Juan Silvero. Kepada Bapak Dr. Aryo, waktu dan tempat kami persilakan.
Assalamualaikum. Terima kasih Mbak Mary.
Ya.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Puji syukur kita ucapkan kepada Allah Subhanahu wa taala, Tuhan Yang Maha Esa, di mana dengan rahmat dan karunia-Nya kita dapat berkumpul bersama untuk mengikuti acara ini. Pertama-tama saya ingin mengucapkan selamat datang pada kedua narasumber kita, kemudian para peserta serta seluruh hadirin yang mengikuti BRIN EnviroTalk episode ke-36 ini. Nah, hari ini tema uh, BRIN EnviroTalk kita Sustainable Agriculture, Local Solution, dan Global Impact. Topik yang kita usung kali ini sangat selaras dan erat mungkin dengan misi Pusat Riset kita, Pusat Riset Lingkungan dan Teknologi Bersih, untuk menyongsong inovasi dan solusi untuk keberlanjutan lingkungan serta masa depan yang lebih baik, insya Allah. Nah, Bapak Ibu yang saya hormati, di tengah tantangan global seperti perubahan iklim, kemudian kelangkaan sumber daya dan ketahanan pangan, penerapan praktek-praktek pertanian yang berkelanjutan atau sustainable menjadi sangat penting. Sumber daya alam kita yang uh, tidak bisa diperbarui atau butuh waktu lama untuk bisa diperbarui dan terbatas. Nah, dan juga cara kita untuk mengolah itu juga sangat menentukan keberlanjutan ekosistem kita serta kesejahteraan generasi mendatang. Nah, insya Allah hari ini kita sangat beruntung karena dapat belajar dari dua orang pakar nantinya yang cukup berpengalaman dalam mengembangkan solusi pertanian lokal yang memiliki dampak signifikan di tingkat global. Nah, pertama kita akan mendengarkan narasumber kita yang pertama yaitu Dr. Noor Elliza Tajidin. Tadi juga sudah disampaikan oleh Mbak Mary dari Universiti Putra Malaysia yang akan memaparkan penelitiannya tentang pemanfaatan Azolla. Ya, sebagaimana kita ketahui bahwa Azolla ini merupakan an incredible aquatic plant yang memiliki potensi besar dalam pertanian berkelanjutan. Nah, Azolla melalui kemampuannya dalam Phytoremediation dan memperbaiki kekuatan tanah, mampu menawarkan peluang yang menjanjikan dalam budidaya tanaman seperti Choy misalnya, yang tidak hanya meningkatkan kualitas air, namun juga produktivitas pertanian. Nah, selanjutnya narasumber kita yang kedua ada Dr. Elisa Azura Azman yang juga dari UPM Universiti Putra Malaysia. Beliau akan memaparkan tentang inovasi penggunaan pupuk cair ya, yang akan dihasilkan dari sayuran yang tidak layak jual. Nah, penelitian ini menunjukkan pendekatan praktis dalam pengelolaan limbah pertanian dengan mengubahnya menjadi input berharga yang dapat memperbaiki kualitas tanah dan mengurangi ketergantungan kita terhadap pupuk sintesis nantinya. Nah, tentu saja kedua topik yang akan dipaparkan nanti menunjukkan bagaimana riset dan inovasi itu dapat mengatasi tantangan-tantangan yang ada, tantangan lokal, kemudian sekaligus menawarkan solusi yang dapat diterapkan di skala global. Itu nantinya. Nah, kita sebagai pusat riset yang berfokus pada keberlanjutan lingkungan serta teknologi bersih, kami sangat yakin dan percaya bahwa nilai inovasi ini memiliki potensi yang besar dalam menginspirasi aplikasi-aplikasi maupun praktik-praktik baru di sektor pertanian nantinya, maupun di sektor lingkungan. Nah, saya berharap dan saya mendorong semua peserta untuk dapat berpartisipasi aktif nantinya dalam sesi ini. Kemudian kita renungkan bersama ya, bagaimana kita dapat menerapkan wawasan-wawasan dan ilmu pengetahuan ini dalam kegiatan-kegiatan riset kita dan dapat berkontribusi pada dampak global yang lebih besar. Untuk itu, atas nama Pusat Riset Lingkungan dan Teknologi Bersih, saya mengucapkan terima kasih kepada narasumber yang terhormat, kemudian para peserta, serta semua pihak yang telah berkontribusi dalam penyelenggaraan BET episode ke-36 ini. Dengan demikian, BET dengan resmi dibuka. Semoga kita mendapatkan sesi yang produktif dan inspiratif setelah ini. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Wabarakatuh.
Waalaikumsalam.
Baik, terima kasih kepada Bapak Dr. Aryo Beta Juan Silvero atas sambutan yang sangat inspiratif dan memotivasi. Selanjutnya kita akan memasuki sesi utama yaitu pemaparan hasil riset. Untuk presentasi pertama ini akan disampaikan oleh Ibu Noor Elliza Tajidin Ph.D. yang dengan kepakaran beliau dalam bidang crop nutrition dan saat ini juga merupakan selain menjadi dosen di Universitas Putra Malaysia, beliau juga saat ini menjadi visiting researcher di kelompok riset keberlanjutan sumber daya lingkungan. Kepada Ibu Elisa Ph.D., kami persilakan untuk memulai pemaparannya hari ini.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Salam sejahtera, selamat pagi. Terima kasih saya ucapkan kepada Dr. Mary Jayanti, yang saya hormati Kepala Pusat Riset Lingkungan dan Teknologi Bersih, Dr. Aryo Beta Juan Silvero, dan juga yang saya hormati para hadirin dan hadirat yang mengikuti sesi ini. Okay, izinkan saya bercakap menggunakan campuran bahasa Inggeris dan bahasa Malaysia. Okay, so before I start with my presentation, I would like to introduce myself. So my name is Noor Elisa binti Tajidin. Work as a senior lecturer at the Department of Crop Science, Faculty of Agriculture, Universiti Putra, Malaysia. So today I would like to share one of my research on Azolla, entitled Harnessing Azolla for Sustainable Agriculture, which is focused on the phytoremediation of wastewater and also soil enhancement, specific on the Choy cultivations. Okay, so before we start with the research background, so I would like to introduce what is Azolla. I believe all of you already know what is Azolla, so this is just a recap what is Azolla. So Azolla, commonly known as the world's smallest spinach-shaped microphyte, or we can easily define as an aquatic plant. Okay, so what is special about Azolla? Azolla special because it has a symbiotic relationship with the cyanobacteria, which is called as Trichomus anabena. So this bacteria live in the leaf, in the dorsal loop inside the leaf cavity of Azolla. So what is their relationship exactly? So basically, Azolla provide the source of carbon to the bacteria so that the bacteria can consume the carbon and can live and protect themselves inside the leaf cavity, and that uh, the bacteria can fix the atmospheric nitrogen, so that can provide the nitrogen for the azolla to grow even under the nitrogen deficiency environment. So due to that conditions, azolla usually in dry weight, it contain high amount of nitrogen, range between 3 to 6%. And also, beside nitrogen, azolla also contain other essential nutrients such as P, K, C, A, M, G, and manganese. But another special about azolla is it can accumulate a lot of minerals and heavy metals. And some reports reported that range of the accumulation is up to 1,000-fold of metal concentration. So, what interesting about the azolla is it can be grow very, very, very fast. Okay, in even in at the large surface area, and it can double within the weight within 3 to 5 days. So that of due to that reason, azolla can be a good candidate uh, to be used in sustainable agriculture. So what is all about for this research is as we know, agriculture wastewater, one of the contributor to the environmental pollutions. Okay, so in Malaysia, palm oil industry contribute large amount of agriculture wastewater from the mill. Besides that, several statistics also mentions that previously livestock farming also produce a lot of agriculture wastewater, but currently poultry manure wastewater also increase. Okay, so due to that reason, there are a lot of others available treatments, synthetic treatments that are available to treat this wastewater before being released to the fresh water. But we can use Azolla as one of the environmental alternatives, so that we want to see whether Azolla can treat the wastewater, especially on agriculture. When we talk about the agriculture wastewater, okay. Besides that, increase in the what we call as the number of people around the world. So we need cater the demand of the healthy food, okay, to cater the demands of the healthy food. So in order to cater the demand of healthy food or food, so we need most of the farmers choose to follow the conventional intensive agriculture production, which is use chemical fertilizer, sorry. So as we all know, long-term use of chemical fertilizer will lead into degradation of the environment, especially reduce the soil fertility. So basically, what I want to see from this research is whether Azolla can improve the soil and also can increase the yield, which we focus on the Choy sum. Okay, so as a sharing, Malaysian soil, most of Malaysian soil, 70% of Malaysian soil categorized under UT soil and Oxy soil, which is these two type of soil is high in clay, right? Okay, and heavily weighted and low organic matter. So you want to see whether by using Azolla, whether as a fresh Azolla or composted Azolla, whether it can increase the fertility of the soil. Therefore, Azolla can be one of the good environmental candidate. So for the phytoremediation agent and also for the soil amendment. Okay, for the study one, okay, so focus on the Azolla as a green solution for agriculture wastewater. So the objective of this study is to evaluate the phytoremediation effects of the Azolla on selected agriculture wastewater. For, as I mentioned in the background of the research just now, so before this, livestock is major wastewater in Malaysia, but currently poultry manure become a major contributor to the wastewater in Malaysia. But the most important number one is from the palm oil mill influence. So that's why I choose this wastewater. Then we put in a special tray, 15 liter for each wastewater, and then we include 2 grams of Azolla for each tray. So we observe this experiment throughout 15 days of experimental days. Then each parameter were repeated 4 times. Okay, so okay. Yeah. Kejap. Okay, sorry for the technical issue just now. Okay, so the first parameter that we observe from this research is the surface covers by the Azolla at the each different agriculture wastewater. So from this study, we found that this study. Okay, so we found that poultry wastewater and livestock wastewater have the highest surface covers by the Azolla. Meanwhile, the tap water, the surface cover increase slightly, but then it becomes stagnant. But from the picture, we can see that there are not much growth of Azolla in the tap water, even in the tap water. But for the pome, it's very, very poor condition, especially for 100% of pome. So represent that pome wastewater is very, very toxic to Azolla, and then Azolla cannot grow very well in that pome wastewater. Okay, and then we go to the oil and grease content in the wastewater. We found out that there are similar trend, there are decreasing trend of the oil and grease content in wastewater when treated with the Azolla. So, and then the similar trend also can be seen in a fecal coliform count from different wastewater. Okay, so from this result, we found out that Azolla is capable of absorbing fat, oil, and grease, as well as range of dissolved compound from oil polluted wastewater, and oil that have degraded and been taken up by the plant's root can be used as nutrients to help the plant growth. Okay, we can see especially on the poultry and livestock wastewater where the Azolla take all these saturated fats, L and oil, and then use converted into the nutrient for them to grow. Okay, and then for fecal coliform show a decreasing trend because maybe due to the Azolla itself have what we call have a secondary metabolite such as tannin that can be used to has a work as an antibacterial and also can limit the pathogenic development inside the wastewater. Okay, so we move to the COD or chemical oxygen demand. From this result, it's very interesting to see. Suppose when we put Azolla, the COD should be reduced, but for certain, especially for the pome, the 100% and 50%, they are significantly increased in COD demand. So maybe this is due to the one is detrimental effect on Azolla biomass or senescence of the biomass, as we can see from the picture just now. Whatever Azolla that we put inside the wastewater for the pome wastewater, the Azolla cannot grow very, very well. It's very poor in condition and is degraded and undergo the senescence process. The second one maybe is due to the dead Azolla submerged in the water, which is later on it will release high mineral and solid content in this water, so that it contribute to the high COD demand, especially on the from the 5 days up to 15 days of the experimental days durations. And then we move to the heavy metal content. For this study, we analyzed 4 different heavy metal content, which is lead, copper, zinc, and cadmium. Okay, so from this result, we can see that there are similar trend for lead and copper for the poultry and livestock wastewater. However, there are different for 100% pome. Okay, we can see lead and copper inside the wastewater increase throughout the 15 experimental days. Okay, for copper, there are similar trend also for the 50% of the pome that we can see from this line. Okay, similar with the 100% of pome. Okay, for zinc there are significant increase, okay, the content of zinc for the tap water and also for the 100%, no, sorry, for the poultry manure and also 50% of pome. But there are decrease in zinc concentration in 100% pome. For cadmium, almost treatments except for tap water show a significant increase of this cadmium content inside the wastewater. For poultry manure, at the end of 15 experimental days, they are significantly slightly decreased in the cadmium content. So, from this heavy metal result, we can conclude that Azolla absorbs heavy metals throughout the uh, experimental days, okay, and Azolla capable to remove zinc, lead, and cadmium. There are several studies that reported that Azolla have capability to absorb all these heavy metal contamination from the industry influence after 30 days of the exposure. But in this experiment, we found out that lead and copper removal from is very good in animal wastewater by Azolla is much more higher than zinc and cadmium removal after 15 days of the exposure. So, as a general conclusion, high accumulation of heavy metal by Azolla is posed in 100% of POME and also 50%. So that's why it contribute to the toxicity, which is not suitable. Azolla is not been suitable to be used to as a phytoremediation agent for the POME. Unless maybe if we diluted at a certain percentage, then maybe it can work. Okay, so greater Azolla biomass when exposed to livestock and poultry manure. So we find out that higher removal of heavy metals, especially for lead and copper from the wastewater. So we can suggest to use Azolla for especially for the small farmer that has small cattle farm or poultry farm. So to use Azolla as one of the environmental agent to phytoremediate atau to remove all the heavy metal from their wastewater. However, 100% and 50% of POME are not suitable to Azolla is not cannot be used as a phytoremediation agent for the 100% and 50% POME because it's toxic, very toxic, which is lead to necrosis and reduction of the biomass weight of Azolla. Okay, the second one of the study is to see whether the Azolla amendment can be enhance the soil characteristic or increase the performance of the Choy sap. So the second objective for this study is to determine the effects of fresh and composted Azolla on soil chemical properties and growth performance of Choy sap. Okay, why we choose Choy sap? Choy sap is one of the most popular, I think, one of the popular vegetable in Malaysia. Okay, so for this study, we select several treatments. For number one is non-amended soil as a control. The second one is 150 kilo per hectare NPK fertilizer. So this is based on the recommendation by the Department of Agriculture for choice sum fertilization program. Then we choose fresh Azolla at 3, 6, and 9%, and then we use a composted Azolla for 1 to 3%. So the selection of percentage of fresh and composted Azolla was based on the previous literature review that have been done by the previous researcher. So this experiment conducted in using a polybag study, which is we use 1 kilo soil into the polybag. Before that, we mix with the treatments, and then this polybag was arranged inside the net house. So it's need to be watered twice every day at 8 a.m. and 5 p.m. And all the parameters, there are two factors here for this study. One is the soil amendment and another one is planting season. So all the parameter measured in this study was repeated 8 times. So the initial characteristic of the fresh and composted Azolla, from this study we find out that most of the parameter including pH, EC, total carbon, what we call CN ratio, PK, CAM, CA, calcium is high in composted Azolla compared to the fresh Azolla. But however, there are no significant difference between total nitrogen content from the fresh and composted Azolla and also magnesium content. So this is summarized of because this study involved of two factors, so we only focus on the interaction effects between the two factors. So this is summarized on the parameters that been measured for the soil chemical properties for two planting seasons. So among the parameter, only EC are not significantly different. No significant interaction effect between the soil amendment and also two planting season, and also urease, one of the soil enzyme activity. So from this study, for the season 1, we can see that most of there are no significant difference between the treatments except for the compost Azolla at 3 and also NPK. So NPK produce lowest pH, okay, but for the second season also show a similar trend. Okay, but the pH is still reading at the acceptable limits. Okay, so recommended soil pH is between 5.5 to 6.5, which almost all the nutrients available at that range, at that soil pH range. Okay, so for CEC, we can see that there are slightly improvement on the CEC when it reached to the second planting season compared to the first planting season. And then for the total carbon, we can see that composted Azolla contribute higher total carbon compared the rest of the treatments. Okay, so soil treated with Azolla and NPK are high in total carbon compared to the initial value. Okay, but we can see that total carbon for 30% composted Azolla dominated at the planting season 1 and also planting season 2. Okay, for the total nitrogen, NPK, we can see NPK contribute the highest total nitrogen content for both planting season. However, we can see that at the planting season 2, there are no significant difference between composted Azolla and NPK treatments in planting season 2. So that's mean 3% composted Azolla can comparable with the NPK fertilizer applications. Okay, for available phosphorus and exchangeable K, 2% and 3% composted Azolla improve available Phi and exchangeable P in the soil than fresh Azolla. We can see that fresh Azolla have less number of available P and also exchangeable K compared with the composted Azolla. And then NPK fertilizer also consistently increase available P and exchangeable K because we use NPK green at 15 rate of nitrogen, phosphorus, and potassium. So that's why they keep on provide the nutrient to the plants. Okay, but however, we can see composted Azolla show comparable result or even better performance due to its sustained release of nutrient over the time. Okay, for soil enzyme dehydrogenase activity, so we can see that from the planting season 1 and 2, composted Azolla have a high, have a increased dehydrogenase activity compared with the control NPK and also the rest of the treatments. So what we can conclude from the result is about 50% of Azolla biomass decomposed after 4 weeks of being applied into the soil. And for fully composted Azolla, which is fully composted, have high concentration of stable organic matter and more effectively to release N due to the N mineralization. and release nutrient at steady rate. So that's why we can see some result of the nutrients very high at this planting season too, and it also can prevent leaching. So higher carbon source also will promote the microbial activity, which is reflects to the high dehydrogenase enzyme activity from the previous results. For fresh azolla, it adds the carbon to the soil, but it need longer period. So smaller total carbon increase within the same time frame increase. So it take times to be degraded into the soil. So decomposition is very slow, and it delay the nitrogen release, leading to the lower nitrogen content in the soil. So because slower decomposition, it also contribute to the slower microbial activity, reflect the decrease in the dehydrogenase activity enzyme that we can see from this result. However, for the NPK fertilizer, we all know FEK can be readily available for the plant to be uptake, but it do not contribute to the organic matter to the soil, and we can see reduce in the soil pH just now. So it's become acidic, soil more become slightly acidic, and low dehydrogenase activity, which is contribute to the or represent the low microbial activity in the soil, which is not good in the long run. Okay, so overall reduction of soil nutrients might be due to the leaching through the irrigation or nutrient uptake by the crops, and NPK fertilizer provide crop with readily absorbable nutrient. However, over the time we can see the pH for the NPK fertilizer decrease. Okay, so it become more acidic as compared with other treatments. Okay, we move to the plant growth performance, Choy some growth performance. So from this study, I only choose selected parameter to be presented in these sessions. So we focus on the fresh, dry shoot length, and leaf area. So from this study, we find out that composted azolla at 3% contribute very good yield for the choice sum, as reflects in these results compared with the rest of the treatment. Similar trend we can see from dry shoot weight and also leaf area. So that we can conclude when application of the 3% of composted azolla can produce high yield of choice sum, much more bigger leaf surface area, which is become one of the selling parameters by the consumer. Okay, for the shoot length, for the first season and second season show a similar increase of trend throughout the treatments. Okay, throughout the 20 days of the planting of the choice. Okay, from this figure, we can see that choice sum that treated with the composted azolla, okay, at 3 and 2, and also MPK green have a better growth performance compared with the rest of the treatments. Okay, in the planting season 1. And then so for the planting season 2, we can see azolla at a 3% apply uh, uh, 3% composted azolla applied to the soil produce a better growth yield compared with the rest of the treatments. Okay, composted azolla at 2% and 3%, we can say consistently improve the weight and leaf area at the first planting season. NPK was effective in both planting season, particularly a second planting season, but as we know from the soil result previously, it's not good. It will contribute to more soil acidity, okay, and reduce the soil microbial activity. But for fresh azolla show limited improvement compared to the composted azolla and NPK fertilizer treatment. So from this study, we see that composted azolla is much more give a good yield and better growth for the choice sum. So this study have been published at the Hatahod journal. So maybe if anyone interested can go and read further, because I'm only selecting certain parameter to be presented in these sessions. So as our overall conclusions, Azolla able to grow well and reduce the heavy metal concentration, but only in the livestock and poultry wastewater, which is can be introduced to the farmers so that they can use Azolla as one of their method to reduce the contamination of the fresh water. So the second experiment, we found that 3% composted Azolla treatment shows significant higher in soil EC, total carbon, nitrogen, exchangeable K, CEC compared to the other soil treatments, and also have a better growth and yield compared with the NPK fertilizer treatments. Way forward from this research is we want to try for bigger scale Phytoremediation study, more complicated study to see whether is it true Azolla can be used as a phytoremediation in wastewater treatments. The second one, to utilize composted Azolla and explore diverse type of soil and also different planting subject to validate and confirm the optimal result. And this last but not least, we want to try to combine the composted Azolla together with the synthetic fertilizer to see whether we can reduce the application of the chemical fertilizer by using composted Azolla. I think that's all from me. Thank you.
Okay, many thanks to Dr. Elisa Tajidin for a very interesting and informative presentation. Terima kasih Dr. Elisa Tajidin untuk presentasinya yang sangat menarik dan informatif. Next, we will listen to the second presentation delivered by Dr. Elisa Azura Ahmad. She is also a lecturer at Faculty of Agriculture, Universiti Putra, Malaysia. Dr. Elisa has expertise in agronomy, who is also visiting researcher in sustainable research group. Okay. Selanjutnya kita akan mendengarkan presentasi kedua yang akan disampaikan oleh Dr. Elisa Azura Asman. Beliau juga merupakan staf pengajar di Fakultas Pertanian Universitas Putra Malaysia. Dr. Elisa ini memiliki keahlian dalam bidang agronomi yang juga merupakan visiting researcher di kelompok riset keberlanjutan sumber daya lingkungan. Kepada Dr. Elisa, waktu dan tempat kami persilakan. To Dr. Elisa, please allow time and place.
Assalamualaikum and good morning to the audience. My name Dr. Elisa Azura from UPM, Universiti Putra, Malaysia. So today I would like to share with all of you about the study from waste to resource, the efficacy of local-based liquid fertilizer from unmarketable vegetable. Okay. So the content of the today talk will be a little bit about my profile, and then I would like to share also some of the scientific finding, and next is how we translate our finding to the community. Next is the recognitions or awards that we want, and also the way forward. Okay. All right. So I've been worked as an academician since 2017, and I've graduated from the University of Tokyo in 2016 for my PhD. And much recently, I have been attached 6 months with the Indian Indian Agriculture Research Institute in New Delhi, and in the 2023 to 2024. And here are some of the information about the publication and also the supervision. Okay. my talk is about food waste. If we talk about food waste, this is the worldwide issue about food waste. Everywhere have the food waste. Okay, in Malaysia, we do have about 15,000 tons food waste every day, and about 80% of waste is contributed by the unused part of fruits and vegetables. Okay, so if we talk about food waste, they have many categories. But for this study, I would like to share about the my team and I particularly work on the unmarketable vegetable at the farm level and also at the supermarket level. Okay, so we found because we have too much waste, so we want to transform it or recycle it into the organic fertilizer. Okay, we tried several approach using by composting. Okay, all right. What is the benefit of the productions of the organic fertilizer from the food waste? First, we can reduce the amount of the food waste. We can reduce the emission, especially on the methane emission, which contribute to the global warming, and then we can increase the farming. All right. What is the unmarketable vegetable? Okay, they have several level or several layer. Okay, first we go to the farm level, and then also they have a lot of waste there because some of the farm when their produce or their product cannot be sold, so they will just dump it and throw it. So we have some suggestion, and we take it as a problem statement to turn this waste, their product, into the fertilizer. And then we also have some survey at the wholesale market, okay, where at the wholesale market also have so many waste on the fruits and the vegetables. Okay, the environmental impact of the food waste, as I mentioned just now earlier, is contribute on the greenhouse gases and climate change, and the landfill and the dump site. Okay, so the objective of this sharing is, in general, we would like to investigate the efficacy of the local-based liquid fertilizer derived from the unmarketable vegetable can be used as the source of nutrient for the crop or not. Okay, so for my sharing today, I have prepared for several findings from the several projects from my team. Okay, first we characterize the liquid organic fertilizer. So how we did generally, we collect what is the fruit and vegetable available from, at the market. Okay, and then we will cut it into small pieces, and we will mix with the water and also the inducer. So the inducer here, they have three types of inducer we are using. The first one is the brown sugar. The second one is the yeast, and the third one is the shrimp paste. Then after that, we will ferment it accordingly to our desired time. For this characterization study, we fermented for about 30, 45, and 60 days. We want to know what happened at that respective day. Okay, so the findings show that, the results show that when we no inducer at all, we put yeast, brown sugar, and the shrimp paste. Okay. Among these three inducer, I would like to call it inducer. Okay, yeast give the good increment in pH, good value of EC, and also some other nutrients such as N, P, K, magnesium, and calcium. Okay. At the above here, we okay, the value is based on the range. Okay, from the literature. Okay. So from here, we can see that the yeast gives the, regardless of the fermented time, okay, whether 30, 45, or 60, it gives a very good, or it's fall in the desired value of our desired parameter. Okay, so from this result, okay, we further on into the planting the vegetable. Okay, we want to know, okay, for the next one, the project 2, we we incorporate or we treated the soil with the liquid fertilizer, okay, and then the treatment was liquid organic fertilizer, which is 100%, meaning that fully of the liquid fertilizer, and also we reduced up to 50% at the fermented time of liquid fertilizer, 30, 45, and 60, and they have a combination also with the plant which receive 50% of NPK or 100% of the NPK. Okay, so I would like to highlight the significant finding from this project. Okay, the first one for the fresh wheat. Okay, it shows that there is no significant difference among the treatment when we see the plant or the soil received with the standard fertilizer, meaning that which is recommended by our government for plant and vegetable. Okay, and then we incorporate and in this blue dotted area here, I highlight that even though we reduce 50% of the NPK fertilizer and we incorporate with the 50% of the LOF, it shows the same or similar effect to the common practice. So meaning that they have from this project showed that this liquid fertilizer have the potential to be as the fertilizer for the vegetable. Okay, for the next, we also analyze on the enzymes, on the catalase activity. Okay, so why catalase activity? Because catalase activity, catalase enzyme is a protective enzyme where it will split the hydrogen peroxide into the water and the oxygen. Where if too much of hydrogen peroxide, it can be highly toxic. So we measure the catalase enzyme, and it shows that the addition of the liquid fertilizer, okay, especially 50% and incorporate with the chemical fertilizer, it shows a significant difference among the 100% or common practice of the fertilizer. Okay, next is on the urease activity. Okay, why urease activity? Because urease activity enzyme is responsible for the hydrolysis of urea fertilizer that we apply. Okay, so it shows that when we added 100% of the liquid organic fertilizer, okay, regardless of the fermentation time, it shows is highly significant amount of uric activity compared to the common practice. Okay. All right. So the conclusion for this study are the soil treated with 50% LOF and 50% NPK shows to give a positive result in the catalase activity by 5.26% compared to the original soil, and applying 100% LOF shows significant increase in urease compared to the other treatment. So this study revealed that LOF combined with NPK fertilizer promote sustainability. Okay, for the next project is about the effect of fermented plant juice and pulp on the Brazilian spinach. So they have we fermented the vegetable and also the fruits. Okay, and then we apply juice, the liquid, and also the solid product to the Brazilian spinach. So what we found is when on the soil pH, the first one on the soil pH, okay, when we are applying only the chemical fertilizer, okay, the pH is significantly decreased compared to the treatment when we apply with the various combination of the organic fruit and vegetable fertilizer. Okay, about the yield, yes, of course, it shows that applying with the NPK or standard fertilizer, it should give the highly significant in the weight compared to the other combination of the fruits and the vegetable fertilizer. Okay, and we in the same project we analyzed for the plant nutrient. Okay, the first one that shows no difference, no significant difference among the treatments. Okay, for the phosphorus, aluminium, and also iron. Okay, whether we apply with the fertilizer, chemical fertilizer or organic fertilizer, it gives the similar effect. Okay, and the next point is on the magnesium. The soil treated with plant juice, okay, regardless of the vegetable or fruits, okay, it is increase the magnesium content compared to the soil received on the chemical fertilizer. All right. So for the next project is the effect of the liquid fertilizer on the corn. Okay, so for this one, we tested the liquid fertilizer for 1 month, 2 months, 3 months. So we want to know whether the time increasing will give the good benefits or not. Okay, all right. And then from the result, okay, for the number of kernel and the crop of weight, this is on the yield parameter. Okay, the first one, we can see that the soil treated with the local-based liquid fertilizer shows the similar effect, okay, compared to the standard fertilizer, SF. The standard fertilizer, meaning that the fertilization is recommended by our government. Okay, and the second point I would like to share is this liquid fertilizer gives a similar effect on the number of kernel and the crop weight compared to the standard fertilizer. Okay, they give the similar effect. So meaning that our local-based liquid fertilizer is comparable, or we can incorporate and it can be source of nutrient for the Okay, for the next project, we are testing the liquid fertilizer, particularly come from banana and also from the papaya. Okay, so what we did, we just collected the banana and the fruits, banana and the papaya, and this picture shows that at the 3 days and also at the after 1 month of fermentation. Okay, so initially we found that this table shows the upper one shows the nutrient content in the banana liquid fertilizer and in the papaya liquid fertilizer. Okay, and then the treatment is the combination of the banana liquid fertilizer and also papaya liquid fertilizer with reducing amount of the standard fertilizer by 30% to 50%. Okay, so what we found is the reduction of standard fertilizer by 30 to 50, as it shows in this graph. Okay, but with in combination of banana or papaya, okay, gives similar effect on the number of kernel per crop and also the fresh weight crop, okay, compared to the 100% of the standard fertilizer. Okay, so the next is on the nutrient. So it shows that here the figure shows nitrogen, phosphorus, and potassium. For the nitrogen and the phosphorus, there is no significant effect among the treatment. And for the potassium, it shows that reductions of 30 to 50% of standard fertilizer shows a similar effect compared to the common practice, which is 100% standard fertilizer. Okay, so we can conclude that from this several projects that reductions of standard fertilizer in combination with the liquid fertilizer gives a similar effect compared to the 100% of standard fertilizer. And this liquid, meaning that we can say that this liquid fertilizer have the potential to be a source of nutrient for the crop which means further we are able to reduce the waste or unmarketable vegetable, where we can transform the waste into the liquid fertilizer. Okay, and then from the scientific finding, okay, we translate or we transfer our knowledge, we share the knowledge with the community, and some of the project with the community have been funded by the UNESCO, by our university, UPM, and also by the respective stakeholder. Okay, so much recently this is shows the at one of the area where the farmers, they have their own field. They grow several types of crops. For example, they are growing cucumber, they are growing cassava, they are growing dragon fruit and others crop. And then they are facing with one problem where some of their product cannot be sold because of the misshape, okay, or not meets the requirement standard. So normally they will throw away. So we come and we give the suggestion and we do the project with them. We share the knowledge with them to transform this waste. We ask them to bring their own waste, this one, okay, and then do their own fertilizer. And this fertilizer they can use to apply on their field. And since this project is still ongoing, so soon enough we will know how the effect and how their acceptance about this project. Okay, for the next, we also share the knowledge with the community for this on this several events. For example, much recently they have the floral exhibition, okay, at Malaysia, Putra. Okay, and besides that, we also share our knowledge on how to make this fertilizer to the kids. They are around at the age of 5 or 6. Okay, so the thing is, we just want to educate them, okay, about do their own fertilizer and eventually to produce their own food. Okay, and then also with their parents, we are sharing teach or we share the knowledge with their parents also. And besides that, not only at the national level, but I also share the knowledge about the liquid fertilizer with the stakeholder in India during my attachment in India. Okay, and then we also went to the school where the school requires us to teach them, to teach the student. And the good thing is, what we are teach them about the how to use or utilize this waste into the fertilizer, and they win the competition. Okay, innovation competition. Okay, and they have some others. Okay, this is we also share the knowledge and we translate this knowledge to the community with the special disability. Okay, special disability. For example, there are autism people. Okay, we teach them on how to do this fertilizer. Okay, and then before we did physically during the COVID, we also did several virtually. Okay, to the audience about, because that time many people really want to know how to grow the vegetable, and if they want to grow the vegetable, they should use less chemical. Okay, so we teach them also. We organize the event on how to produce your own fertilizer at home. Okay, all right, and then besides that, okay, so the recognition for in research and also in UK, we won several awards gold awards, silver awards, and also the awards when we are, this one is the award of the community project where we teach the community and we won this award, bronze award. Okay, what is the way forward? They have several things also need to be done. Of course, I also looking forward for the IP commercializations of the product. Research advancements, meaning that, of course, this research is still fundamental. Yeah, even though this is commonly practiced by the people, somehow we did not have any, I can say very less data or finding scientifically. Okay, and then of course we also would like to try to other crop, maybe for the rice and for the other short-term crop. And for the next, also we are looking to study or to know how this application of the fertilizer effect on the global warming, on the environment, on the methane emission. Okay, when we already reduce the waste to do the fertilizer, of course, it's already reduced the methane, but we don't have any specific, scientific data. And then we will do that. Okay, and also we are ongoing to produce the module for the community on not only on how to do the fertilizer, but the complete set of growing their safe food at home. Okay, and this other approach, meaning that besides we are transform this waste into the, also my student also have conducted how to utilize or transform the food waste. Okay, the food waste which already cooked and not cooked, and we make it into the sandwich compost, and we tested on the several crop and the several seed. Okay, and additions on that, currently we are ongoing on the one project also, transformations of the food waste, okay, and also the agriculture waste using the black soldier fly larvae to convert and to produce the fertilizer. Okay, soon enough, maybe in future, we will share the knowledge about these two approach. Besides the liquid fertilizer. Okay. Last, I would like to thank to our team member for the data, for the research project, and also always with me for the community project. I think that's all from me. I can be contacted through this email, and also you can have a look on my YouTube about the some of the how I make the fertilizer and some other material also. Thank you very much.
Okay, well, thank you very much, Dr. Elisa, for the excellent presentation. Thus, we were listen to presentation. Now it is time for discussion and Q&A session. For those of you who want to ask question, you can write on your question in the chat column or raise your hand virtually. Terima kasih kepada Dr. Elisa atas pemaparannya yang sangat luar biasa. Dengan demikian kita telah mendengarkan dua presentasi yang sangat bermanfaat dan mengesankan. Kini tiba waktunya kita pada sesi diskusi dan tanya jawab. Bagi Bapak Ibu yang ingin bertanya, dapat menuliskan pertanyaan di kolom chat atau mengangkat tangan secara virtual. Di kolom, apakah ada yang ingin langsung bertanya? Silakan angkat tangan secara virtual. Jika belum ada yang bertanya, ini di kolom chat sudah ada. Ya. Di kolom chat sudah ada pertanyaan dari Bapak Novianto Giar dan Ibu Nuril. kepada Dr. Noor Elliza. Kepada Dr. Noor Elliza kami persilahkan. Please take your time. Oke, ini besar ya. Question. Oke. Question dari Bapak Giar. Ya. Oke. Norvianto. This one. Oke. Share again ya. Ini. Tidak bisa lihat. Oke, pertanyaannya. Baik, di kolom chat sudah ada pertanyaan dari Bapak Novianto Gier. Questionnya perlu dibacakan. Oke. Jelas nggak? Sudah. Oh, oke. Oke, perlu dibacain. Oke. Pertanyaan question kepada Ibu Dokter Noor Elliza. Pertanyaan pertama, the first question.
Kalau kita jawab dalam
Oke.
ini, boleh dalam bahasa
Boleh
Melayu,
dalam bahasa Melayu,
bahasa Inggris.
boleh dalam bahasa Inggris ya. Okay. The first question for Bapak Novianto Giar, if Azolla has accumulator ability metals, how are the dynamic of heavy metals when Azolla wastewater Phytoremediation waste is composted or used as green fertilizers? Second, how is the condition of symbiosis of cyanobacteria when Azolla is used for phytoremediation and waste from phytoremediation activity for organic fertilizer, especially the ability of cyanobacteria to fixation-free nitrogen? And the third, what factor influence the heavy metal hyperaccumulator ability of Azolla and its prospect for remediation of rice irrigation water? That's four, yeah.
Okay, thank
How the
you.
effect of ultra and oxidation characteristic which is high in all and effectivity of Azolla fertilizer. Thank you. This is the
Okay,
question for me.
thank you Bapak Novianto. Alamak, hilang pula soalan. Kena tunjuk. Okay. Ya, sebab Elisa
Share lagi. Oke.
saya tak nampak soalan ni.
This one. Nampak. Or I get.
Okay, for question number 1, so usually we when we test about Azolla as to test as a hyperaccumulation for heavy metals, usually we will not use this for the compost. Okay, especially we check the level of heavy metal first. If the heavy metal is more than permissible limits, then we cannot use that, and we we follow the rules and regulation by the government to treat this Azolla waste. Tak nampak soalan. Okay. The second one, but from our study, we found out that heavy metal concentration in Azolla are not more than permissible limit and can be allowed to be used as a compost material or as a mulching material. So because the concentration is very, very low. That's why in way forward, we would like to see if the Azolla can go the concentration of heavy metals at different ways that high heavy metal content, so that we know whether the Azolla can be how much the heavy metal content can be absorbed by the Azolla. But from our study, the concentration is very, very low. So is allowed by the our environmental uh, department to be used as a composted material. Alamak, hilang lagi soalan. Di-share lagi kan? Di-share. Soalnya di-share lagi. Iya, sinyalnya lupa. Hilang. We are sorry for sinyal. Signal. Ya, bateri pun tak tahu. Okay. How the condition of symbiosis with the cyanobacteria when Azolla used for phytoremediation. Okay, usually there are for phytoremediation, there are several methods of the phytoremediation agent. For let me check. For example, for lead, how they uptake the heavy metals from the wastewater is to the rhizospora. That's mean the uptake through the roots. Okay, but for bacteria, is live inside the uh, dorsal loop in the leaf cavity, the cyanobacteria. So it's different part. Okay, for phytoremediation, they focus on the root zone, but for the cyanobacteria inside the leaf cavity of the Azolla. Okay, so use waste from the phytoremediation activity for organic, especially the ability of cyanobacteria to fix. Okay, so cyanobacteria only live with water conditions. Okay, when the Azolla is dry and whatsoever, bacteria tu pun gone, macam hilang, okay, mati. So it's only based on the carbon and mineral and so the secondary metabolite of the Azolla that only left. Okay. Okay, so what factors influence the heavy metal is different. It depends on the different type of heavy metals elements. So as I mentioned just now, for plumber and copper, the ability of absorption of heavy metals is different from others element. Okay, so it's not the same. So different heavy metals, what we call the elements, have different way how the Azolla been absorbed of that heavy metals. Okay, so utisol and oxisol characteristic with high aluminum and ferrum to effectively, so carbon from the composted and also microbial activity will help to increase the what we call the characteristic of the soil. So from this study also shows that usually the soil in Malaysia is slightly acidic, but when applied with the Azolla compost, the soil pH is increased at the acceptable or more neutral soil. So it also increase the other elements availability on that soil pH. Besides that, the contributions, when we talk about compost, is not much on the mineral elements, but the synergistic of the compost itself. So for this study, we only focus on the pH, microbial enzyme, and so on. But we also need to measure others parameters like phytohormones inside the compost and other elements that synergistic that can help to increase the fertility of the soil. Okay, I hope my answer that can answer the questions. Okay, for Ibu Nurul, how to handle, okay, usually if we test the concentration of the heavy metal for the Azolla waste, and then if the Azolla waste, the heavy metal concentration is high, is more than permissible limit, then we follow the rules that been stated by the governments. If not, we can convert it into the compost or other materials. From our study, the concentration of the heavy metal is below than permissible limits, not uh, more than permissible limit that set by the government of Malaysia.
Nggak ada suaranya.
Ya, suaranya hilang. Izin menyampaikan, suaranya hilang, Bu Panitia.
Oh
Terima
iya,
kasih.
mohon maaf. Ya, terima kasih Pak. Di sini Pak, sinyalnya agak hilang-hilang juga sebetulnya. Bismillah. Selanjutnya, next question to Dr. Elisa. So, this time for yours. From Bapak Noor Fianto Giar tuh kepada question to Dr. Elisa. Terlempar. Oh, sorry. Dr. Elisa terlempar dari chat. Oke. Using my
Okay, all right. The connection is not this. Okay, I would like to
ditambahin.
answer and also different nutrient content from different sources. Okay, I'm not that and aware about microbe consortium, and when I share this knowledge with other stakeholders.
Suaranya putus-putus ya.
Okay, so apologize for the technical problem. I continue here. All right. Micro consortium and different content from different sources. Okay. Actually, we are now, because for the first stage or initial stage, we already know, we already have the data that it shows a good in terms of yield. Okay, and then for our next step is about to identify what kind of microbe, okay, what kind of microbe presence, okay, because when we fermented, we noticed they have a white layer on this surface, so it's most probably they have a micro or any fungi. So for the next step, we are going to identify, quantify the microbe and the microbe consortium. For the second one, yes, actually, we are reversing the project, the research. At first, we are mixing all together the vegetable and the fruit for sharing our knowledge. So we received several idea or several comments. So I reverse back. We trying to testing. Okay, test. For example, now I share about the papaya. What is the nutrient content of papaya? And also the all right. So we tested. So we want to know what is the single effect rather than we make. We are so sorry. Besar cabarannya. Okay. And then if you ask me whether is a different nutrient from content from different sources, yes, they have a different nutrient content. Okay, for the next question, Professor Dr. Tarzan asking about did I use any or apply any bacteria or fungi for the fermentation? No, actually, I apply the material, for example, the brown sugar, the yeast, and the shrimp paste. Why I apply this or why I mention this? Because this is available uh, for the people to use at home. This is available at the kitchen. So that's why I more mentions on the these three inducer. Okay, actually, to replace the brown sugar, we can use molasses. But if I say to the community, okay, you can use molasses, all right? So the community don't have any idea about what is molasses, where to get this molasses. Okay, that's why the material or inducer I use is which is available for the community. All right. About these bacteria or fungi, yes, in future I plan to incorporate with the maybe microbiologists here, so we can apply any bacteria or fungi to enhance the fermentation, to improve the quality of the liquid fertilizer. Okay. Next is Dr. Nuril asking about which fertilizer recommended. Okay, for the moment, we don't have any recommendation because our main objective is for the moment now, to use to know the efficacy of the liquid fertilizer. Okay, and also we want more community use this fertilizer at home. Okay, we don't have any recommendation. Our main is, okay, whether you throw away your waste, why not you transform it into the fertilizer? Okay, all right. Dr. Dodi, the question is uh, about, okay, he mentioned about his team also do the similar to what we did, okay, and they are calling that coenzyme. All right. I can say yes, we are similar. Maybe the inducer might be different because the inducer I use, which is available at home, okay. And also they are calling coenzyme. Yes, some of the stakeholder, they also call this as the coenzyme. And for the next also, of course, we are going to analyze what is the content of what is the part of enzyme and quantify how much this enzyme in our particular fertilizer, liquid fertilizer. Okay, because earlier we already have that this liquid fertilizer able to help and improve in the soil enzyme. Okay, so for the next, because way forward is they have many other many research that we are planned, and we are going to conduct stage by stage. Okay, the next question is from Dr. Ania about how do you measure the methane emission from vegetable waste or food waste? Okay, during my visit to India last time, I also learned from them, okay, on how to measure this GHG from the waste. Okay, we can collect the waste and then we can dump the waste. Okay, if we want to know what happened if we dump the waste, okay, we dump the waste and then we can use the chamber, the closed chamber, and we will measure. All right. If we want to know what happened if we apply this waste we already transform into the fertilizer, we can measure along the fermentation period of this liquid fertilizer. We can measure the methane emission, and when we apply to the crop, we can measure during our planting period. Okay, I hope this is justify and I answer well to the questions given. So if any of you or the audience have some idea wants to collaborate regarding to this project, I am most welcome. My team and I want most welcome. Okay. Begini, tak pakai ni. Yang mana? Yang mana soalannya? From Azman and Lodi. Oh, ni tadi ulang balik. Oh, okay. From Professor Dr. Tanzan. Okay. The question about did I use any bacteria or fungi? For the moment now, I'm not using any particular bacteria or fungi. But I aware that some bacteria or fungi can enhance the fermentation and the quality of the liquid fertilizer. Okay.
And then from Dodi, you use liquid organic fertilizer from vegetable or fruit waste.
Yeah.
This
one
our
also
research, we use the same materials,
Yeah.
but we added sugar and carbonate and
okay.
for at least 3 months. We call this an ecoenzyme. Is this process the same as making ecoenzyme? Thank you, because there is signal trouble.
Okay, because of the signal trouble. Okay, I share again from the question from Dr. Dodi. Okay, you can see from what you are explaining here, I can see that our method similar. Okay, our method similar, and you have fermented for at least 3 days. In my objective, I want to ferment I want to ferment less than 3 months, meaning that the people or the people at home or the community at home or the farmer, they are not need to wait for a long time to use the fertilizer. Okay. Yes, I also have one project. I try what happened 1 month, 2 months, and 3 months. Okay. All right. And yes, it's also called coenzyme. And as I mentioned just now, we are way forward to measure what type of enzyme and quantify how much that enzyme, because we already have the data on how this fertilizer effect on the soil enzyme. So most probably they have some sort of enzyme initially in our liquid fertilizer. Okay.
One question again from Bufroni to Elisa. I need to know the field of metal that is absorbed by the Azolla that could affecting the soil and what the best standard we can use for metal contamination threshold in human health. Thank you.
Okay, for this question, thank you, Bapak Guforni. Okay, so usually, from my research that I conducting, we find out the heavy metal concentration is very, very low. It's not more than permissible limit. So we always use back our Azolla waste as a green mulching or compost material. But it depends on the rule and regulation of that country. For our we already check with the Ministry of Environment. So they are already listed what is the permissible limits for each heavy metal concentration, whatever that we test. So if they are below than permissible limit, it can be disposed accordingly. But if the permissible limit is more than above that have been set by the government, so we need to follow the rules and regulations. So how to dispose that material. So what is the best standard we can use for metal contamination threshold in human health? So it is also go back to the rule and regulation and permissible limit stated by the government. So I cannot remember what is the concentration in Malaysia, the permissible limit concentration in Malaysia. But as long as I know, from whatever study that I have done, the heavy metal concentration is very, very low compared to the limit that have been set by the government. So uh, maybe for human health, we need to check through the blood, right? So whether the how much heavy metal inside the blood, so is it can more than should be or not? Okay. I'm sorry, I cannot explain more details on this subject because I totally forget the range of permissible limit stated by the government of Malaysia. But I for sure whatever data that I include in my experiment is data is allowed by the government is low than permissible limit uh, by the government. Bagi Bapak Norfianto, ya nanti kami akan share apa ni slide presentation. Kami akan share our slide presentation later. I hope I answered the question. I am so sorry if I not give a more clear answer for that question for Bapak Forni. Okay, thank you.
Belum. Baik, dari peserta virtual meeting, apakah masih ada yang perlu ditanyakan lagi? Habis ya? Tidak ya? Oke. Jika tidak ada lagi, kita akan mengucapkan terima kasih kepada narasumber. Many thanks for both speaker for their valuable presentation and to all participants for their active presentation in today's discussion session. As a closing, we will hold a group photo session. As we ask all participants to turn on their camera to document the event. Terima kasih kepada kedua narasumber atas paparan yang sangat menarik dan sangat berharga hari ini, kepada seluruh peserta atas partisipasi aktif dalam sesi diskusi dan tanya jawab hari ini. Sebagai penutup, kita akan mengadakan sesi foto bersama. Kami mohon kepada seluruh peserta untuk menyalakan kameranya untuk mendokumentasikan acara. Belum ya? Di layar saya ada berapa nih? Halaman pertama ya. Oke. Baik. Untuk layar pertama, saya akan menghitung ya. Satu, dua, tiga, selanjutnya untuk layar ketiga, 1, 2, 3. Next screenshot. 1, 2, 3. Banyak ya Mbak ternyata. Oke. Next. 1, 2, 3. Oke. Selesai ya. Dah. Okay, many thanks to all participants in this discussion session. Terima kasih banyak. Dengan berakhirnya sesi ini, berakhir pula acara BRIN EnviroTalk ke-63. Saya selaku moderator, Madya-PRLTB, mengucapkan terima kasih kepada seluruh hadirin yang berpartisipasi, baik secara virtual maupun langsung. Semoga hasil riset yang telah dipresentasikan ini dapat memberikan manfaat bagi pengembangan penelitian dan penerapannya di masa mendatang. Untuk paparan materi nanti akan di-share di grup Civitas, dan untuk pertanyaan lebih lanjut bisa langsung diajukan di di email yang sudah diberikan oleh Ibu Elisa dan Ibu Eli. Terima kasih banyak atas kehadirannya. Wassalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan sampai ketemu di kesempatan berikutnya.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ya,
Mohon
izin live.
izin.
Izin live.
Akhirnya.